Okay, so we've covered graphing circles and ellipses. Hyperbolas are a little different because, as we've covered, to know that it's a hyperbola would mean that you have both an x squared and a y squared term, but one of them must be negative. So that makes it a little more interesting when you're trying to complete the square to get it in graphing form. It also means that where circles and ellipses both are going to be positive x squared and y squared, so we always just write x squared first. For a hyperbola, we need to pay attention to the order, and if x squared is the positive variable, we write that first, which would be this form of the equation. But if the y squared is the positive variable, we want to make sure we write that first in the graphing form of the equation. So something to also pay attention to is that the center is still HK, but H is the value that is associated with X and K is the value associated with Y. So that's going to be fine if the X variable is written first, but if the Y value is written first, you're so used to going in order, you really have to pay attention that your center is going to be in reverse order from what you're used to, because the center is still going to be the horizontal shift that is attached to the x variable with the vertical shift attached to the y variable. Then we also have asymptotes with hyperbola. So we still are going to move the square root of the denominator under x in the x direction from the center, and we're still going to move the square root of the denominator under y in the y direction from the center, regardless of the order. But to get the final result, we have to know if x came first or y came first, and that's going to determine if we sketch the vertices to the right and the left of the center or above and below the center. So let's take a look at a couple of examples. So example 1, it's in standard form. The center is 0, 0, x is written first. So that's going to feel very normal. We know by looking at this equation that it is a hyperbola versus an ellipse just because of that minus sign between our fractions. The center is 0, 0, so you want to plot that first. Take the square root of the denominator under x. That would mean to go 3 in the x direction. So right and left of the center. Take the square root of 4, that's under y, so go 2 in the y direction from the center, so 2 above and below the center. So if this was an ellipse, if that was a plus sign, we'd be finished graphing as soon as we drew our ellipse through those outer 4 points. Okay, but a hyperbola has 2 asymptotes. In this type of hyperbola, those asymptotes form an x. So what you want to do is you want to take these outer 4 points and use it to sort of create a rectangular box through those 4 points. And then your asymptotes are going to be the x formed by connecting corner to corner, so the diagonals. Okay, so those are the asymptotes. Then we want to make sure that we're aware of which variable x or y came first. If x comes first, then we want to draw our asymptote through the vertices, approaching the asymptotes right and left of the center. So since x came first, I'm going to draw my hyperbola through these 2 vertices. I'm going to hug my asymptotes. So I'm drawing them to the right and the left of the center because in my equation, x came first. So I had said before, for the circle, I'll ask you to name the center and the radius. For the ellipse, I'll ask you to name the center and the length of the major axis. For the hyperbola, I will ask you to name the center and also the slope of the asymptotes. So you should know at this point that slope is rise over run. So that means the change in y over the change in x. So the change in y was 2. I went 2 in the y direction. The change in x is 3. I went 3 in the x direction. So the change in y is 2. The change in x is 3. So that's 2 over 3. I also have two asymptotes. One has a positive slope, the other has a negative slope, so the slope of the asymptotes will be positive and negative 2/3. All right, let's take a look at example 2, which is also in graphing form. So here, y is first. So here's where you really have to pay attention because we're so used to going in order from left to right. But the center here is 1, -4. So that's going to feel very backwards from what we're used to. But the x-coordinate of the center is going to be with the x, still opposite of the sign. The y-coordinate of the center is going to be with the y, still opposite of the side. So graph your center. We're still going to follow these same rules. The number under y tells us how we're going to move in the y direction. So the square root of 16 is 4. So I'm going to go 4 above and 4 below the center. There's a 9 under the x. The square root of 9 is 3. So I'm going to go 3 to the right and 3 to the left since that's the x direction from the center. I'm going to make that rectangular box through those vertices. And then I'm going to draw my asymptotes. That's going to be from corner to corner, so through the center, through the corners of that diagonal box. And then since y is first, then we are going to go through the vertices, approaching the asymptotes above and below the center, okay, in the y direction. So through the vertices above and below the center, hugging asymptotes. So it's not difficult to graph hyperbolas, but you do have to pay more attention than you do with the circle and the ellipse. So slope of asymptotes here, I'm going to abbreviate, it's always going to be plus or minus. The change in y, I went 4 in the y direction, change in x, 3 in the x direction. So from the center, you can look, and from corner to corner of this box I made, up 4, right 3, up 4, left 3, down 4, right 3, down 4, left 3. The slope is plus or minus 4/3. All right, for example 3, this is not in graphing form, so I'm going to need to complete the square to get it in graphing form. Just to give myself more room, I've written this on a separate paper. So here's the problem right here. So we're going to start it just like we always do. We're going to write the x terms next to each other, leave room to complete the square, write the y terms next to each other, leave room to complete the square, constant on the other side. So just like always, when you're completing the square, the only thing that you can have as a coefficient on your square term is a positive 1. So I have to factor 4 away from the 2x terms. And I'm going to have to factor a -1 away from the 2y terms. Because a hyperbola always has a negative squared term, you're always going to have to factor out a negative from one of the variables. That's going to affect the sign from the linear term. So pay attention for that. -1 times positive 4y is -4y. Now I can complete the square. Half of 4 is 2, 2 squared is 4. But to balance, that needs to be a 16. Half of 4 is 2, 2 squared is 4. To balance, that has to be a -4. So I have 4 times x minus 2 squared minus y plus 2 squared equals, and this comes out to be positive 4. Right, then remember the last step is to make it equal to 1, so you want to divide everything by that constant. So I have x minus 2 squared over 1. You can choose to write that 1 or not, equals 1. So this is my graphing form, x minus 2 squared over 1 minus y plus 2 squared over 4. Remember that if you're using this process and you get a negative constant, then you're still going to divide by that to make it equal 1. That's just going to change the order of the variables, which we've talked about is very important for a hyperbola. Okay, so I've written that graphing form right here. We have the center x is first, so that's going to feel normal, 2, comma, -2. I'm going to go from the center 1 in the x direction to the right and the left of the center, 2 in the y direction above and below the center. I'm going to draw this tiny little box through these vertices and then through the center, and from corner to corner I'm going to draw those asymptotes. Since x is first, I'm going to draw through the vertices to the right and left of the center, hugging the asymptotes. And the slope of my asymptotes, plus or minus, I went 2 in the y direction and 1 in the x direction. You can write plus or minus 2 over 1 or just plus or minus 2. All right, you should also be able to write the equation given the graph. So again, pay attention to which direction it's drawn so you know which variable to write first. In this case, the center is at 3, -1, and it's drawn in the x direction, so I should write x first. So if the center is 3, -1, and x is written first, it would be x minus 3 squared over something minus, if you put a plus, it's not a hyperbola, y plus 1 squared over something equals 1. And then you have these, you either have the vertices drawn or you'll have the box drawn in, but you can see here I went 2 to the right and the left in the x direction, so 2 squared is 4, and it looks like I went 3 above and below, and 3 squared is 9. So that would be the equation. Okay, hope that was easy enough for you, and you have the circles practice, you have the ellipse and hyperbola practice.